Welcome to a new session of network synthesis analysis. Today we're going to see Foster form 1 and Foster form 2 basic representation, which is shown in Foster form 1 and Foster form 2 like this, and we'll apply this Foster form 1 and 2 to RL, RC and LC, and we'll compare the results. So what we are going to do, we are going to start with the different examples. For example, we are going to start with Z of S is equal to 2 times of S plus 1 into S plus 3 divided by S plus 2 and S plus 6. We have already solved this example in our previous video. You can check into that. So what is the result we got? We got Z of S, which is equal to 1 by 2 plus 1 by 4S divided by S plus 2 plus 5 by 4S divided by S plus 6. So we are treating these individual impedances as Z0, Z1 and Z2, and the Foster form 1 basic representation is this. Now the Z1 and Z2 can be solved with Z1 formula and Z2 formula, which is shown over here. Now after solving for Z1 and Z2, we can frame the Foster form 1 for RL function in this fashion. Now when the Foster form for RL function is realized in this form with the output as Z of S, which is equal to given by this value, we can compare with the original equation of result of Z of S, which is given by R0 plus R1S divided by S plus R1 by L1 plus R2S by S plus R2 by L2. Now with this, I can frame the result of Foster form 1, which is shown over here. You can see we have the Z of S, which is equal to 1 by 2, that is taken as 1 by 2 ohms. Then we have R1 and L1 that can be obtained with the help of this condition, where R1 it is obtained to be 1 by 4 ohms, and in inductance L1 is obtained by as 1 divided by 4 multiplied with 2, which is gives the value as 1 by 8 henries. Similarly, 5 by 4 S by S plus 6 can be framed as 5 by 4 ohms, that is the resistance value, and the inductance value as 5 divided by 4 multiplied with this will give the value as 24. So 5 divided by 24 henries is a representation of Foster form 1 RL function. So what if we want to get the Foster form 2 representation? So that can be obtained with the help of admittance value, just the reciprocal of the impedance. Not exactly the reciprocal, I can say the inverse of the impedance function, and the Foster form 2 representation of RL function, which is shown in the series combination of the parallel network. And the result for this can be derived from our previous videos. The result is obtained as 1 by 2 plus 5 by 4 divided by S plus 1 plus 3 by 4 divided by S plus 3. So treating the values as y0, 1 and 2 respectively, and the solution to this y1 and y2 can be obtained by this formula. Y of RL of S can be replaced by 1 by Li divided by S plus Ri by Li. Just replace the values of I as 0, 1, 2, 3. We can get the formula representation. So y1 and y2 are framed like this, and this is the Foster form 2 representation for RL function. Now with this, I'll reframe my original equation, which has obtained in the form of answer, that is y of S value, and that can be represented by this Foster form 2 representation of RL function. You can see y0 it is 1 by 2, so it is replaced as 2 ohms. Then we have 5 by 4 divided by S plus 1. Just equate with the help of this equation. You will get the value of resistor and inductor for y1 of S and y2 of S respectively. Now let us go with the example 2 for RL function, where we have Z of S is equal to S plus 1 multiplied with S plus 4 divided by S plus 3 multiplied with S plus 5. So what are the constraints to find out the solution that you can go with our RL realization video? With that, we get the answer as Z of S is equal to 4 by 15 plus 1 by 3 S divided by S plus 3 plus 2 by 5 S divided by S plus 5. After getting the solution, let us frame the impedance into three parameters as Z0, Z1 and Z2 respectively. And so, to get the solution for Z1 and Z2, we have to use this formula. And with that, I'm going to get the solution of Z of S, which is equal to R0 plus R1 of S divided by S plus R1 by L1 plus R2S by S plus R2 L2, whose representation of Foster form 1 you can see in this particular figure. Now, with this answer, we can get the original Foster form 1 for the given function with the answer Z of S is equal to 4 by 15 and so on. The first parameter is the impedance, which is changed to resistance value as 4 by 15 ohms. Then the resistance value is changed to 1 by 3 ohms for this function, and the inductance values just multiply this 1 by 3 with uh, uh, 1 by 3, which will give the value as 1 by 9 henries. The similar fraction you can apply for this 2 by 5s by s plus 5, which are going to get the value as 2 by 5 multiplied with 5. In the denominator, we get 25a. Overall, 2 by 25 henries. So this is the Foster form 2 representation for example 2. Now, what if I want to get the Foster form 2? For that, I have to change the admittance parameters. That is, the denominator goes to the numerator and the numerator comes to the denominator. Sorry. For the solution, we are going to get the value of y of s, which is equal to 1 plus 8 by 3 divided by s plus 1, 1 by 3 divided by s plus 4. Now, retreating the admittance value as y0, y1 and y2 of s, and the original answer is compared to the actual answer of y of s, which is 1 by r0 plus 1 by L1 divided by S plus R1 by L1 plus 1 by L2 by S plus R2 by L2. Now for this, the admittance representation under Foster form 2 is shown over here. Now this can be compared with the original admittance circuit, and we can get the value of admittance parameters of R0, which is nothing but equal to 1 by R0, which is equal to 1 ohm. 1 by 1 divided by 1, anything will give the answer as 1 ohm. Similarly, the resistance and the inductor value of this particular admittance function, and 12 ohms and 3 henries for the rest of the admittance parameters can be framed like this. Now what happens if we have the example with the RC functions? Let us treat this as case A. Why? We are going to see the in-depth of the different forms of RC functions. In case 1, you can see you have the numerator s plus 1, s plus 3 divided by the denominator s into s plus 2. Anyhow, the Foster form representation for RC function is shown by this particular representation. Now the solution is obtained by z of s is equal to 1 plus 3 by 2 divided by s plus 1 by 2 divided by s plus 2. Anyhow, after treating the impedance individually and with the help of this formula of z of RC, we can get the value of z of overall function as R0 plus 1 by C1 divided by S plus 1 by C2 divided by S plus 1 by R2 C2. Just compare the actual result with the function of z of S. We are going to get the Foster form representation for RC function in this fashion. Just replace the values where we have resistance as 1 ohm, the capacitance value as 2 by 3 farads. The resistance for the parallel combination is obtained as 1 by 4 ohms, and the capacitance value for this parallel combination is obtained to be 2 farad. Now the same example, when we go with the admittance representation, you can see the y of s is changed by 1 by numerator, and the answer for this we obtained as 1 by 2s by s plus 1 plus 1 by 2s by s plus 3. So for this, the admittance representation is given by this formula, and you can replace the R1, C1, R2, C2 by the values as 2 ohms, 1 by 2 farads for the first leg, and 2 ohms and 1 by 6 farads for the second leg. Similarly, you can take an example of Z of S, which is having the numerator values with S plus 1, S plus 3, where the zeros are at -1 and -3 respectively, and the poles are at s equal to 0, s equal to -2, s equal to -4. For this type of impedance function, we are going to treat as case B. And when you look into the solution, which we have already discussed in our second video under network synthesis analysis, we got the solution as z of s is equal to 3 by 8 divided by s plus 1 by 4 by s plus 2 plus 3 by 8 by s plus 4. Anyhow, the first form representation it is shown over here. Now just z naught is replaced by c naught, and the solution we can obtain in the form of this formula z of rc, which is given by 1 by ci divided by s plus 1 by ri and ci. Just I is a representation of the next parameter. Now with this Foster form 1 representation for RC function, we can just substitute the values for the first parameter, that is the capacitance, as 8 by 3 farads. Then we have the parallel combination of resistor and capacitance, which can be replaced by 1 by 8 ohms in parallel with 4 farads. Then 3 by 32 ohms in parallel with 8 by 3 farads. What is our main intention? It is a series combination of parallel network. So thus we have obtained the Foster form 1 representation for RC functions under second example of case B. Under example 4, again we have to look into the actual representation of impedance function. In the numerator we have one pole at origin, one pole at -2 and one pole at -4. And the numerator we have at -1 and -2, which are representing the zeros. Anyhow, the admittance function is quite 1 by z of s value, and the solution we have obtained here as s plus 3 by 2s divided by s plus 1 and 1 by 2s by s plus 3. Now that can be compared with the actual formula of y of s, which can be shown by this particular equation, and this has been derived from YRC of s formula. Just replace the value of Ri as 0, 1, 2, 3 based upon the given problem, and the Foster form 2 representation for RC function it is shown over here. Just replace the values with the actual answer, which we got here of C0 as 1 farad, then C1 as 3 by 2 farad, R1 as 2 by 3 ohms, and C2 as 1 by 6 farads, and R2 as 2 ohms. Likewise, we can go with another example where we have z of s is equal to 2 times multiplied with s plus 4 multiplied with s plus 2 divided by s plus 1 and s plus 3. Let us consider this as case 3 or case C of RC function, where we have the answer which is shown over here z of s, which can be compared with the actual formula of ZRC of s, which is shown in this particular equation. We have framed this formula based upon RC of s, which is given by 1 by Ci divided by s plus 1 by Ri Ci. Now the Foster form 1 representation for RC function for this particular example, it is shown over here. Just replace the values, you are going to get the Foster form representation for RC function under case C. And similarly we can get the value of admittance condition and the representation of admittance parameters for Foster form 2, which is shown over this particular representation. Now we'll go with the last example. In generally, we are going to get the impedance function in terms of square plus the numerator and denominator values. This can be solved, which we have seen in already our third video of network synthesis analysis. You can go to that particular video, and the solution what we have obtained is z of s is equal to 3s plus 16 by 3 divided by s plus 56 by 3 s divided by s square plus 9. Anyhow, that taking into the consideration, the formula is framed with ZRC of s, which is shown over here. Now this is framed based upon ZLC of s, which is given by this common formula. Now with this, we can frame the Foster form 1 LC impedance function, which is shown by this normal representation or general representation, that when we are going to substitute with the original answer, we are going to get the impedance function of LC network for Foster form 1 in this form formation. The similar thing you can apply for Foster form 2. Here I have taken the same 1 by zs of value and the solution obtained as y of s, and after treating the individual admittance value as y naught of s and y1 of s, I have framed with the help of this formula and the general form of Foster form representation of LC admittance function. With this, I have substituted the original values. You have to figure out what is the formula beyond this admittance function. Comment in the chat box whether you are able to solve this kind of Foster form 1 and Foster form 2 problems for different impedance functions. That's all for today's class. I hope you like this particular session. Please share among your friends, subscribe to this channel and press the bell icon for the future notifications. Thank you.